Hi guys, so this is the worksheet that I left you for subwork. And it'd be great if you wanted to try these questions on your own first and see how far you can get. But you can also just sort of follow along with the video too. So I'm only going to do the odds on this worksheet. Actually, it's going to be two worksheets, so I'm only going to do the odds. So here it says, use the definitions of the three trig ratios to complete each statement, okay? So for number one, we have side lengths and angle A, but we don't actually know these lengths. We are using variables to represent the lengths, but we can still write an expression for sine A. So if we know, if we remind ourselves of our trig ratios, we use SOHCAHTOA as a mnemonic device here. So sine is opposite over hypotenuse. So the sine of angle A is going to be the opposite. That's the side that isn't used to make angle A, which is m, over hypotenuse, which is always opposite the right angle, which in this case is p. So m over p is sine A. Cosine A is adjacent over hypotenuse. So adjacent is the leg that's adjacent, not the hypotenuse. So n over p. And tangent is the opposite over adjacent. So opposite is m, and adjacent is n. So question 3 here, we have sine, cosine, and tangent of B and sine, cosine, and tangent of A. So first of all, I have two of the side lengths, but I do not have the third side length. So I'm going to find the third side length, which is the hypotenuse, by using the Pythagorean theorem of these two leg lengths. And again, I know this is the hypotenuse because it's always opposite the 90-degree angle. So I'm going to use a squared plus b squared equals c squared, the Pythagorean theorem, plug in 8 and 15 for my a and b value, square the 8, I get 64, square the 15, I want to say that's 225. So if I add the 64 and the 225, I get 289, and so c squared is 289. And you might not know this, but that's actually a perfect square. So if I take the square root of 289, I get 17. So c is 17, so the length of AB here is 17, the hypotenuse is 17. So 8, 15, 17 is a Pythagorean triple. It's a case where we have three integer side lengths in a certain right triangle. This happens sometimes. So sine B, B's here, is going to be opposite 15 over hypotenuse 17. Cosine B is adjacent 8 over hypotenuse 17. And tangent B is opposite 15 over adjacent, which is 8. Now A is the other acute angle in this triangle, and we learned in class that the sine of one acute angle is the cosine of the other and vice versa. So sine of A is opposite 8 over hypotenuse 17, which you can see is the cosine of B. Cosine of A is adjacent over hypotenuse, so 15 over 17, which again is the sine of B. And then tangent is opposite over adjacent. That's always going to be the reciprocal of this tangent value, because what's opposite of one angle, so what's opposite of B, is adjacent to A. What's opposite of A is adjacent to B. So on to question number 5. We're finding the sine of angle angle X. So sine of X is opposite over adjacent, opposite over hypotenuse. We need to find this number, which is missing. So again, we're going to use the Pythagorean theorem to do this. We have the two legs, so we're going to add these guys together. Okay, and we get here, I'm going to call that c squared. This is 49, and then 24 times 24 is 756. Oh, 576 is what I meant. And then if I add that to 49, so I'm just doing this in a calculator so I don't make a mistake, I get 625. And that is actually a perfect square of 25. So c is 25. So this is another Pythagorean triple, 7, 24, 25. So the sine of x, again, opposite over hypotenuse, 7 over 25. Cosine of x is adjacent over hypotenuse, 24 over 25. And tangent of x is opposite over adjacent, 7 over 24. Okay, so you'll probably notice too, after you've been doing this for a while, that, you know, these match, but also this is the numerator of this divided by the divided by the numerator of this, right? Because it's opposite over adjacent, or opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So I'm going to kind of use my little hack here and recognize that these are going to be the same value. These are going to be the same value. And these are going to be reciprocals. Done. So onto the back of this page, the directions say to use trig ratios and a graphing calculator, which we can just use a regular calculator, to approximate the leg lengths to the nearest tenth, okay? It says these are all right triangles. That's important because it's not labeled, and unfortunately we're not told which angle is the right triangle, so for here we're going to go based on appearance. So we're going to assume that that's our right angle there. So what we have here is we have a 65-degree measure, right? We have the side adjacent to it, and we're missing the side opposite. This isn't labeled, that is the hypotenuse, but we want to sort of think about which trig function, because we have the angle, will help us find the opposite given the adjacent. So if we think opposite and adjacent, that's tangent. So I can use that to write a little equation that says tangent of 65 degrees is opposite A over adjacent, 20. And now if I want to get A alone, I multiply both sides by 20. These cancel and I get A is 20 times tangent 65 degrees. And then I can use a calculator to approximate that value. So when I plug this into my calculator, I'm using a calculator on a phone, and I'm plugging in like this. Originally it looked like this, and I knew that couldn't be right. You can't have a negative side length, but you see this button, I had it in radians and I needed it in degrees. So since it says radians, that means I would click it to turn it into radians. And if it said degrees, that would mean I click it to turn it into degrees. So this makes a lot more sense. So the length of that side that I'm looking for is 42.89. It did say to round it to the nearest tenth, so I'm going to call that 42.9. So A is about 42.9, and the units are inches. Now, even though the directions said approximate each length, I'm interpreting that as each length that's denoted with a variable. So like finding x, but not necessarily finding this longer leg length. So again, here I have 70 degrees, and I have the adjacent, and I need the hypotenuse because, again, I'm going to assume that's my 90-degree angle based on appearance. So if I'm thinking about which trig function uses adjacent and hypotenuse, that would be cosine. So I have cosine of 70 degrees, I'm writing my equation, is going to be adjacent 36 over hypotenuse, x. So you'll remember from class when we're dividing by our variable, it doesn't really help to worry about the 36. We need to get the x out of there. And the best way to do it is to multiply both sides by x. Okay, so now we have x times cosine 70 is 36. Now since I want to get x alone, I divide both sides by cosine 70. So x is equal to 36 divided by cosine 70. So when I plug this into my calculator, I'm getting this value for, let's see, that was 36 divided by cosine of 70, so 105.3. So x is going to be about 105.3, and this was yards. That seems really big compared to 36, but keep in mind that this is a 70-degree angle, so this would only be 20 degrees, and that the side opposite the smallest angle should be the shortest. And also, we just found the length of the hypotenuse, which should be the longest. Chances are this side would be closer to this value than this value based on the 70 degrees. Opposite 70 should be closer to opposite 90 than opposite 20, just in terms of the linear measure of the side. And last but not least, the last question we're going to do on worksheet 1 is question 11. And again, I'm looking for D. It appears that that's the 90-degree angle. I'm sort of looking for the corner, right? Like this would be like the corner of a square or a box. So given this, let's see, I have this angle measure. I'm looking for the opposite. So I know it's opposite because this side doesn't make this angle. So I'm looking for opposite, and I have adjacent. So let's see, how am I going to do that? Opposite and adjacent, I believe that's tangent. So the hypotenuse is not involved at all. So I'm going to say tangent of 40 degrees is opposite D over adjacent, 128 feet. So I'm going to solve for D by multiplying both sides by 128. And so D is going to be about, and then I just plug that into my calculator. And when I do that, I get 107.4, and my units are feet. So D is about 107.4 feet.